a fairly simple PV diagram problem to get you started. There will also be a couple of videos of more difficult PV diagram type problems, but this is a good one to get started with. So the first thing I'm going to do is figure out what my change in internal energy is between points A and B. What is delta U? So I'm going to use the fact that we were given some information on that path from A through C over to B, and what we're given is that Q is positive 90 and the work done is positive 60 joules. We know that Q is delta U plus W, which means that delta U is going to be Q minus W, or positive 30 joules. So what that means, let me just write it out here. Delta U, delta is always final minus initial. So that's the same thing as writing the internal energy at B minus the internal energy at A. B is higher energy than A by 30 joules. Okay, now let's take a look at part A. Part A says we take the path from A through D over to B, and we want to know what is Q. Well, delta U we know now. This is also going to be positive 30 joules. And W is given, so we end up with 45 joules. And that's heat that's added to the system because it's positive. In part B, we're given the fact that when we come back from B to A along that curved path, there's some work done. We don't know if it's positive or negative, 35 joules. So let's figure out if it's positive or negative. Where's our drawing? There it is. We're starting at point B, we're going to point A through this curved path. And you'll notice that when we go from B to A, that's a compression. The gas is taking up less volume at the end. The volume's getting smaller, which means we are doing work on the gas. The gas is not doing work, it's not expanding. So the sign of the work is negative. So we know that the work is really negative 35 joules. We have to do work on the gas. So now we can find Q, delta U plus W, and delta U, what's delta U? It's negative 30 joules, and W, negative 35 joules. This one, we just said, the volume is getting smaller, right? So the work is negative. And this one, why is it negative? Because we are going from B to A. So delta U, in this case, is going to be UA minus UB, which is the opposite of what we found earlier. So it's negative 30 joules. So what's our answer? Q, negative 65 joules. And the negative sign means that that is heat that comes out of our system. So it's liberated by the system. This is heat that flows out of the system into the environment. Now let's look at part C. They give us some values here. They say if the internal energy at A is 0, and the internal energy we know at B then would have to be positive 30 joules, because we know there's a 30 joule difference between those two. And then they give us one more. They give us the internal energy at point D as 8 joules. And they want us to figure out what Q is for the different paths from D to B and from A to D. I'm going to do D to B first. So Q is going to equal delta U plus W. And delta U, I'll write it out here. It's UB minus UD, right? Because it's always final minus initial. And the work done in this case is 0, right? We're going up. Let's just take a look. Where's our PV diagram? From D to B, the volume never changes. So the work done on that path is 0. And so we end up with 22. 30 minus 8 is 22 joules. We have to put 22 joules of heat into our system going from D to B. And let's look at the path from A. That's an A. No, it's hard to tell. There. From A to D. Q is delta U plus W. And delta U in this case is the energy at D minus the internal energy at A. And that's going to be 8 minus 0. And the work done was given for the entire path, 15. And we know for the second part, from D to B, it's 0. That means from A to D, it has to be 15. And what do I get? 23 joules. And then just as a quick check, in part A, I think we calculated Q for the whole path as 45. So let's add them up. Q from A to D plus Q from D to B is equal to 22 plus 23 is equal to 45 joules. And that's what we got. Let's see. That's what we got in part A. So it looks like everything's working out here.